So let us discuss more about input and output streams. The sources of errors in input-output error handling. First is our mistake, means human mistakes, and we may have files that fail to meet certain specifications or requirement, and also some requirements or specifications that actually fail to match the reality. And of course, human mistakes, or you can say programming mistake or programmer error. All these are sources of errors. So IO stream, what it does, it reduces all errors which are possible to one of the four states. These are the four states. First is good, means the operation is success or it didn't fail. Then EOF means end of file. That means we hit the end of file. We reach to the end of file. And fail, that is something unexpected has happened. Then bad, something unexpected and also serious has happened. For example, let us take the example of sample integer and how it reads the failure. If you have this number as input and you have this star as one of the input and you're expecting integers, then the state is actually fail. The state goes to fail. And similar is by the format error, though this is not so grieve, but still the state is fail because you are expecting an integer and you are receiving a 5.6, that is a float number. Then end of file has no problem because we can have end of file EOF special character and control Z if you are talking about Windows, and if you are thinking on Unix, then control D. And state is end of file, which is a pretty safe state. There's something really bad when you have this format error, blue screen, and state is bad. Let us take an example, quite not very simple example, quite clumsy you can say, but we'll try to clean it up in later stages. Fill vector. This is iStream. Hope you remember this iStream, IST. We have made a vector called V and also a terminator character. So we read integers from IST into V until we reach this end of file or the terminator. Again, this same stuff we are doing. So we read until some failure has happened, means int I, IST, and we are reading I from the file, and this v.pushback, we are pushing it onto V also. Then if this ist.end of file, if it goes to end of file, it receives or it confronts with the end of file. We found the end of file. Now if ist is bad, that is error, this is bad, then we say that the stream is corrupted and let's do something else, or let's go out. And if ist does fail, one is end of file, one is bad, and one was fail, this one. So if it does fail, we clean up the mess as best as we can, and we may report the failure or problem. That is ist.clear. We need to clear all stream states so that we can look for some terminator. We expect some C, read a character, hopefully a terminator, and if it is a terminator, we say okay. If it is good character, it is okay. If character is also unexpected, we could put the character back and then set the state back to fail, like this. ist clear iOS base fail bit. We set this fail. And then throw an exception for bad. How to throw an exception? It's pretty easy how to make this ist throws if it goes bad. ist dot exceptions. This is what you are going to use, and ist dot exceptions, and then with a pipe iOS base bad bit, same as the previous one, but just before that you add this ist exceptions. And this can be read as set ist's exception, mask to whatever it was plus the bad bit, this one plus the bad bit, or as throw an exception if the stream goes bad. We have seen this somewhat, at a first go it may look somewhat tough, but let us simplify or try to simplify. It's not that much simplified, but still let us simplify this input loop. All other things remains the same, and here we found the end of file, and these are reading integers from ist, reading integers into I, pushing it to the stack or this vector until we reach the end of file or terminator. And this is not good, not bad, and not end of file. We conclude that it should be fail. So ist.clear, it clear stream state, and we try to find out the character, and we read the character. Hopefully it should be a terminator, and if it is not, it must fail. So maybe my caller can use that character. Okay, so we set the state back to fail. Not much of a difference, same thing, but only we have got rid of this, and pretty some stuff of failing we have reduced it down to just checking off the character. Then reading a single value. How to read a single value? Let's assume that we ask users, please enter an integer in the range of 1 to 10, and specifically we have asked user to enter an integer or at this range, right? If n is equal to 0, that is we start with 0, and we try to see for each and every value which has been entered, what is the value? Is it between 1 and 10? It's okay, otherwise we say sorry, this is not in the range. But here it seems to be a pretty decent way of doing the stuff. But there are three kinds of problem that may arise. First is the user types an out of range value that we have been seeing here, and getting no value, that is the end of file, getting no value, and the user types something of the wrong type, that means not an integer. So what do we want to do in these three cases we just asserted? We handle the problem in the code, doing the read, let it do it. Then, or we can throw an exception to let someone else handle the problem. We can ignore the problem or read a single value. Is something we often do many times, and we want a solution that's very simple to use. Then handle everything. How can we make program handle everything? Everything which can happen we can handle, or is it possible, or is it a good idea? Let us see that we see out that please enter value from 1 to 10, and we see that whenever a number comes, if cn, then we check for a range, we say sorry, this is not in between, otherwise we say cn fail, we found something that wasn't an integer. So we'd like to look at the characters, and then again sorry, it was not a number. Then again we check, throw away non-digits which may come. So we check for character, and we check for the status, that whether it is a digit or not. If not seen, we say okay, no input, because there was no input, we didn't find a digit, and we put the digit back so that we can read the number with unget, and otherwise we say end of file or bad, give up. So don't try to do everything at once. We have all mixed together, means reading value, prompting the user for input, writing error messages, skipping past bad input characters, or testing the input against a range. The solution is to split it up into logically separate parts. How? What do we want? What logical parts are we talking about? Like this: int, get, int. That means we read an integer, that is, we are using cin. This, what it does, it reads an integer from cin so that we can check the range for integer, or we can also have skip to integer. We found some garbage character, so we skip until we find an integer which we are expecting. And separate functions that do the logically separate actions need to be used. So let us see this skip to integer means we check for what is coming to us. We found something that was an integer. We would like to look at the character now. We throw away the non-digits that we wouldn't want. Then we put the digit back if it is digit, and that we may or we will read the number. For that we will put the digit back, or if these cases are not sufficed, we say error, no input, error file or bad give up. Then we can say get, or get any integer, get int also we can have like this. What explanation, or what we can say that implementation of this get int can be, it will be from we'll just check for true, we'll expect the integer, we say sorry that was not a number and please try again, and we skip to integer, we go to this. Then we can have this get integer in a range. How? A slightly different version. Please enter an integer in this range from low to high, and while true we get int through get int, and we check for high and low and we return n, and we say sorry if it is not in the range, and we present the user with the problem. So how to use it? We can just use this get int with 1 to 10. We take the integer, or get int 2 to 300, we can get the integer. But the problem is the dialog is built into the read operations, but no problem with that. What do we really want in this type of situation? Because we can have some other situation also, like you can have get int 1 to 10, enter strength, not in range, try again. Okay, so when this strength, this is a parameterized by integer range and dialog. This is what we are when we are talking about dialogs, or this read operation which already have this dialog. So we check for get int and 1 to 10, enter integer, not in range, try again, and we can just present this strength, or otherwise we can have this get int from 0 to 5000. See, this trend, this altitude, many things we can have, because what we have to decide, what do we really want. Here we need just 1 to 10, here we need only 2 to 300, here we have gone to strength, here we have gone to altitude, some may go to say height, some may go to weight. So that's often the really important question, because ask it repeatedly during your software development, and ask you learn about a problem and its solution, because solutions can be any. So that improves your answers. So try to parameterize, that is in same thing we are using. Low high, this is greeting, this is sorry. We say greeting, this is low high, we check for the trueness, and we call this function get int. If it is outside, we say sorry. So this is incomplete parameterization. Why? This get int still blabbers, that is utility function should not produce their own error messages. Why it is producing this same error messages? That is why it is blabbering. So serious library functions do not produce error messages at all. They actually throw exception. Please understand this. This is very important. They throw exceptions, possibly containing an error message. This is another stuff, means user defined output, that is operator. Usually we can use them trivially, like ostream ampersand and operator, like this. We can input a ostream os and then constant d, so it can just return os. Hope you remember this problem we earlier discussed. d dot day, d dot month, d dot this. See, so we often use several different ways of outputting a value. This is one of them. So this stays for output layout and detail, very much like this. This is more detailing. Do some printing. These are more detailed printing of actual operator, or this printing operator. So we have this user defined input, this operator also, and what we can do with this operator, same thing, means we can read data or date into format like year, month, day. We can have certain character, we can have from this input we can expect the values, and this, if it is not, we return that okay, we are not getting this value. Or we can check for the format error. We already know how to set state to fail and leave, and if all things remain same, then we update the date and then return the and leave with the good state. So you may find somewhat tricky something, but don't worry, because this is just for explanation. Even if you remember or understand few of it, it will be good. Thank you.